Hi again. So, differentiation by first principles. What I've done so far is I've just written the formula down. And I would encourage you at this point to look back at your books and remind yourself of why that works. Basically, it's got to do with you've got some function, look something like that, and you draw a gradient triangle at x and x plus h. And you look at rise, which is that bit, over run, which is that bit, and then you make it go in so that the triangle is really small. And eventually that triangle, when you draw the line through the 2 points, will be the tangent, and the slope of the tangent is exactly this definition. Okay, but please look back in your books for more information there. I'm just going to show you one example, and then I'll show you a couple more tomorrow. But remembering that these are all generally the same thing, you want to get rid of an h on the bottom, this one. You want to get rid of that by factorising 1 out of the top somehow, divide through, and then just subtract it. And that's what I'm going to do here. So for this one, I'm going to try and work out the derivative of 1 on x. So y dash, is the limit as h approaches 0 of fx plus h. Remember, that means substitute whatever you see for x, write x plus h, minus fx over h. Now I'm going to break my rule and say this equals the limit, my rule being only ever one equals sign in a line, 1 on x plus h minus 1 on x divided by h, which is the same as multiplying by the fraction 1 on h. Now at this stage, I would like to be able to substrate in h equals 0, but if you look at it, hopefully it's very obvious that you can't, because there you would be dividing by 0. So if I'm not allowed to do that, next thing I want to do is I look at this and I say, alright, there I've got a fraction, subtracting two fractions. Whenever I've got a fraction like that, I want to try and get a common denominator. So I do that, I get x minus x plus h in brackets over x plus h, and I can also just pull this h here into the bottom of the fraction like so. And then this equals, I'm just going to write the top line here, and then I'll transfer to the next page. So the top line is minus h. All I'm doing there is I'm simplifying here. So that tells me that y dash is the limit h approaches 0 of minus h over x plus h times h. So I've got a common factor of h on the top and the bottom, so I get a 1 on the top. And now, if I sub in 0, the only place I have to sub it in is here, and that does not make me divide by 0. It makes me divide by x, which isn't necessarily 0. Okay? And in fact, it can't be 0 on this curve, because if you think about the curve, it's a hyperbola, and that's an asymptote. So I can subtract in now, and I get minus 1 on x. Man, this is overkill. But I get minus 1 on x squared, which is exactly our favourite friend, switchy drop. Okay, alright, so that's differentiation by first principles. It is that easy. You might not believe me, but too bad, so sad, it is that easy. We will practice that tomorrow. It's worth having a look in your textbook now if you want to. Here's a picture of my dog. See you tomorrow.